welcome to Math Molecules. In this tutorial, we would cover an introduction to rational numbers. Before we understand rational numbers, let's recall the number system we know so far. As children, we all started to count from 1, 2, 3 and so on. These were called as natural numbers or simply counting numbers. Later, we came up with 0. 0 along with these natural numbers are called whole numbers. Then we had to represent numbers less than zeros. Those are negative numbers. So we came up with the idea of integers. Integers include negative numbers as well as whole numbers. Now let's understand what are rational numbers. Rational numbers comes from the word ratio. It is a ratio of two integers of the form p by q, where the denominator q is not equal to 0. So any number of the form p by q where q is not equal to 0 are called rational numbers, where p and q are nothing but integers. So if I have a number 1 by 4, I can say that it is a rational number because the numerator 1 is an integer and denominator 4 is an integer. Therefore, 1 by 4 is a rational number. How about minus 1 by 3? If I see the numerator minus 1 is an integer, denominator 3 is an integer and denominator is not equal to 0. Therefore, minus 1 by 3 is also a rational number. How about a whole number 1? I can also represent this 1 as 1 by 1 or 7 by 7, minus 6 by minus 6, any of these. It can be represented of the form p by q, where q is not equal to 0. Therefore, any whole number can also be termed as a rational number. How about 0 itself? 0, I can write it as 0 by 1 or 0 by 6. Therefore, it is of the form p by q, where p and q are integers and q is not equal to 0. Therefore, 0 is also a rational number. How about this number, minus 4 by 0? While minus 4 is an integer, and 0 is an integer, but by 0, division by 0 is not defined. So I can say that minus 4 by 0 is not a rational number. Now let's go ahead and check if decimals are rational numbers or not. Before that, let's see the classification of decimals. So decimals can be divided into terminating and non-terminating decimals. Terminating decimals are those where the quotient, when I divide the number, the quotient has a definite value after the decimal point, definite number of digits after the decimal point. It ends at some point. That is why it is called a terminating decimal. For example, if I have got 1 by 2, when I divide, I get 0.5. I have 5 by 8. I will get it as 0.625. 0.625. So here, after the decimal point, the digit ends at some place or the other. Hence, these are called terminating decimals. So all the terminating decimals are rational numbers. Now let's go ahead and check out the non-terminating decimals. In non-terminating decimals, I can have either repeating or recurring. Now how do I get recurring decimals? Like 1 by 3. When I divide 1 by 3, I will get 0.333 and it goes, which I can represent it as 0.3 with a bar on the top. It means that the 3 here keeps on repeating and it never ends. It doesn't terminate. How much ever I do, the division goes on and on. Such repeating, repeating decimals, but they are non-terminating ones, are also rationals. Now let's see what are these non-terminating but non-repeating decimals. In this case, the decimal numbers do not repeat, but they do not terminate as well. For example, root 2. If you see here, after the decimal point, each number is different. There is no pattern. There is no repeating pattern as such, and they do not terminate. There is no end to the decimal numbers which follow. Therefore, these decimals are called as non-terminating, non-repeating decimals. These are considered as irrational numbers. They are not rational. For now, we would cover only rational numbers. I will add a different video on irrational numbers soon. So let's recall this. When it comes to decimal numbers, the terminating decimals are rational numbers. Non-terminating recurring decimals are also rational numbers, while non-terminating, non-recurring decimal numbers are not rational. So now we can say that all natural numbers are rational numbers, all whole numbers are rational numbers, all integers are rational numbers, and any number that can be represented of the form P by Q, like fractions or decimals, are rational numbers. In decimals specifically, the terminating decimals are rational numbers as well as non-terminating recurring decimals are also rational numbers. So rational numbers include integers, fractions, mixed fractions, percentages. We can also represent percentages in the form of P by Q. 8%, I can write it as 8 by 100. Therefore, they are also rational. Terminating decimals and repeating decimals. So finally, we will recall the definition of a rational number. A rational number can be defined as any number which can be represented in the form of P by Q, where Q is not equal to 0. P and Q are integers, so it is a ratio of any two integers where the denominator is not equal to 0. Because if we have denominator equal to 0, then the number cannot be defined. So let's just check out these examples. Now, is minus 3 by minus 5 a rational number? If you see, the numerator is an integer, denominator is an integer, and denominator is not equal to 0. Therefore, minus 3 by minus 5 is rational. How about 7? Is 7 a rational number? Yes, I can write the 7 as 7 by 1, where 7 is an integer, 1 is an integer. Therefore, 7 is also a rational number. How about 0? Is 0 a rational number? We already discussed that all whole numbers are rational. Therefore, 0 is also a rational number. How about 1.2? Is 1.2 a rational number? I can write this as 12 divided by 10, where 12 and 10 are integers and denominator is not equal to 0. Therefore, 1.2 is also a rational number. How about 1 by 9? I would get 0.111 which goes on repeating, which I can write it as 0.1 with a bar here, which says 1 is repeating. So I know that my recurring decimals are also rational number. Therefore, 1 by 9 is a rational number. How about 5 by minus 3? If I see that 5 is an integer, minus 3 is an integer, and the second condition denominator is not equal to 0. Therefore, minus 5 by 3 is also rational. I hope this tutorial was helpful in understanding what are rational numbers, and now you can easily identify the rational numbers. Please find the link of the quiz if you would like to attempt a quiz on rational numbers in the description. Thank you so much for watching Math Molecules.